Alright, let's begin. So what I will do right now is to disable the preview of this code so that I can create another one. How to do this is I will select everything that I don't want to see. So do a crossing window, middle mouse button. So let me go through the other options that we can do. So apart from group, we have preview, which is two of the most commonly used ones as well. We have enable preview and disable. We also have the enable and disable code option. We have the bake, which is how we are going to transport the output geometry in Grasshopper into Rhino again to use. We have the to disable solver. That means no code is running. We have the find. We have navigate, which is a simple way to navigate through the canvas. And the preferences window. Yeah, so in this case, we would like to actually disable everything. So now we don't see any code running in Grasshopper. And we shall begin this whole process of what I just did show you just now, so that we have a good understanding of how this works. So what I will do now is to find some space in the Grasshopper canvas. I would also go somewhere far away. Alright, so if you recall, what we need to do is to create the graph so that we can actually play with the curve that will correspond to the radius of the building for each floor. So what I would like to do is to start to create an origin for the graph. So we can double click, type point, zoom in a bit, and let's say we go to the top view in Rhino. So we know that, this is an imaginary graph, but we know that the higher we go towards the top, the higher the y value is, the more right we go, the higher the x value is of a point in 3D space. So this is a perfect place to do a graph. So I will create a point in Rhino. So what I do is type again, point. By the way, you can see the command bar at the bottom left. This is what I'll do for all my operations in Rhino. So I click a point in Rhino. That will be my origin. So I will reference the point, right click, set one point, set to this point. Okay, so this is my origin of my graph that will correspond to the radius values across different values of the different levels of the building. Okay, so now I have to create the vertical lines that corresponds to the graph. So what I'll do is to create a line, I'll be using the create line from 2 points component. But before that, I need to create a second point, right? So to create a second point from my origin, use the move component, move. You see the point with 2 points and an arrow in between. We click that. Alright, so now we have the move component. So always remember the left side asking for inputs. So we can hover over the input and we can see, base geometry. So this is the point that we want to move. Move the point. So we are looking for a motion. The motion is asking for a vector. So double click, search for vector. So just to differentiate, this vector component is asking for vectors in Rhino. In this case, we're looking for a vector 2 point. But we realize that we will only want to move it upwards in the y direction. So vector 2 point isn't really the component that we want. So let me delete that. Can double click again. In this case, we would like to use the unit y component. Okay, unit y is just a unitized vector. That means it just shows one unit of the direction of y. And we can also play the vector, which means to scale that one unit vector y. Okay, let me show you how this works. So if I hover over this output of the unit y, it is outputting a vector of 0, 1, 0, which means a movement of only one unit of y. So if I click and drag it to the input of the move, so I'm moving this point up by 1 unit. Let me zoom in a little bit. Here we go. You see 1 unit of y. This is the origin. This is this point. You see in green. And so one key thing to note is if you left click on a component, you realize there's a slightly less darker gray, which means there's no geometry in Rhino. Or if it's a very whitish component, something is being referenced in Rhino, and you can actually click to see which one is it. And the move component outputs the new point, which is the origin moved by a unit y vector. So always remember, vector is a kind of like a geometry that requires inputs of a magnitude and direction. So in this case, the magnitude is 1 unit, and the direction is the y direction in the Rhino canvas. Okay, so the next most important input to be more familiar with is the number slider. So if we double click, it's under parameters, but I will always recommend that you use the search command. Double click the canvas. In Grasshopper, you can search number slider. Or another way to do this is to double click, and if you know you are looking for an integer, type 2. If you're talking about looking for a decimal, you can press 0.5. And if you're looking for maybe a bigger number, you can use 2000. Yeah, so this is the quickest, easiest way to use number sliders. So what this does is actually, at the output of this slider right now is wherever you have the point selected at. So the output of this is 6696. The output of this component is 0.5. The output of this is number 2. The output of this is 0.25. And you can also play with the output. So whenever you shift the point, the output will correspondingly change according to this value. So what I would like to do is actually to plug in this one. Okay, let me delete the rest. So parametric design comes into play here. So now we're able to adjust this value. And if we adjust this value, what happens is the vector here changes. Let me put a panel. To introduce a panel, we double click, we type / enter. We have a panel. So the panel actually helps you to watch the output of each component. If you drag a wire from this output, left click and drag, let go. Here we see this is a vector of 0, 6, 0. And let me zoom out a bit. So if you keep changing the value, you recognize that the panel is changing and recognize that the point on the Rhino canvas is also moving up. So this corresponds to the input that is within this number slider. And that's how parametric design comes into play here. Okay, enough of this part. So now let's create a line. So to create a line, we need 2 points. So now we have 2 points, so we can use this function. If you see the black polygon, it's actually always referencing to Rhino. So you do not want that. So we use the line with 2 points. Okay, if you hover over the component, you can see create a line between 2 points. So what it's asking for is 2 points of, in this case, we will want to pass in the input of the origin, again, this green one. Click and drag, let go, geometry. So the outputs for the move component, we have geometry, which is the green point here, and transform, which is the vector with which the point move, which is actually the same as the vector. So what I like to do is to actually select this geometry and to click and drag, put into the endpoint. So what this does is actually created a line between the origin to this point. which is what you want. And now we would like to create the graph in terms of to create the different levels. And knowing that the levels can change in terms of how many levels of the building it can be, that can be parameterized. So firstly, we would like to have a linear array. Okay. Alright. And we would like to have a number slider indicating the number of levels. Number slider. Let me say we have 5 to 10 levels, so we use a single digit. We can just double click and type 5. So we can have the range of from 0 all the way to 10. Okay, so this will be levels. Let me show you a neat trick. You left click the component, right click. Here you see some options that you can use. Right now we can rename the components by hovering at the top and changing the name. Let's name this to number of levels. Alright, and maybe here we can say length of graph lines. Alright. Okay. Remember to move around, we can use the right mouse button to move, to pan, the scroll bar to zoom in and zoom out. We have the left click to select the components. Once we have the number of levels, which will actually affect the number of lines that we will actually output, we can do so. So what this linear array component is requesting for is the geometry, the direction, and the count. So geometry is the line that we would like to array. Array is basically a copying of elements along a direction. We have, in this case, we would like to have the lines move from left to right and to copy and to, depending on the number of lines, but in the same direction as X. So now we're moving from left to right. So we have learned that unit Y corresponds to the vertical motion. And now we would like to use the unit X. Unit X. Alright. So we can also plug it into the direction. Okay, here we see is a preset value of 10. So when we can hover over the input, you can see any preset value of 10. One way to either set the value, you can use right click and select set integer of 10. But in this case, we do not want to set only one value. We can use a number slider. So we can click, drag, connect. You get the drift here. So the Y's corresponds data being transferred from one component to another component. It's basically saying that my inputs, my eggs, from video 1, my beaten eggs go into the oven and goes into my mouth to eat, Yeah, each component is a function. Okay, so now what we have done is we can actually toggle with the number of levels. And if you want to, we can scale Actually, I do not want to scale the unit vector of X. Sorry, let me get out of this place. Alright, then we can create our fancy section curve, so to corresponds to the radius of the floor plates across different levels. So let's say we have 10 levels of the building. We can type interpolate curve, INT, yeah, here it is. So I can draw a random curve. Right. So right now what I want to do is to bring this curve into Grasshopper and to do on to the next stage of the code, which is to analyze the intersection of my input curve and the graph to create a list of Y values to create a list of values for the radius. So what I need to do right now is to have curve. So in this case, we would like to use the curve component that is indicated by the polygon, black polygon icon, I would say. Yes, so right click, set one curve. So now it's asking you to reference a curve in Rhino. Left click, okay. So now we have referenced this curve in Rhino into Grasshopper. Alright, so now I would like to use the intersection curve. So remember, in the intersection we have to use the single horizontal line curve. Okay, enter. So now we have the curve / curve component, which is to solve the intersection of two curves. So the first curve would be the output of the linear array, and the second input for the curve would be the input curve. So what this does is, okay, let me show you a simple trick to find out what you're actually doing. Always use the panel to understand what you're doing. So if I connect this output geometry, these are the lines, a list of 10 lines, right? And let's see, we have a line. This is a reference line in Rhino. Double click, /, panel, enter. I'll connect the output here. Okay, so in the panel we see list. How do you know it's a list? You see the integer. Usually if we see more than one row, it actually means a list already. But in this case, it's something a bit different. This is actually a kind of like a graph list, which means a list, each point is within a list by itself. And then you see a dashed line. This is because this geometry has 8 lines, and then you're actually finding an intersection of like 10 times, and thus it creates 10 different lists. So what you can do is to actually flatten this whole list and to combine it into one. How you can do that is actually to right click the output. When you see reverse flatten graph simplify, in this case we will use flatten. So what this does actually is to take all the points in the different lists and to combine them into one list. So right now you see a list of 10 points as compared to 10 different lists of 1 point each. This is the flatten command that we can apply to the outputs or inputs. Alright, so we have 10 points that corresponds to the position, and we can use the y values of these points as the radius of the building at different levels, from level 1, which is the left one, level 2, level 3, level 4, 5, 6, 7, 8, 9, 10. And we can actually play with the points right now by just clicking it in Rhino, and you can adjust the control points. Yeah, so let me take you to the next step, which will help you understand what you're doing in detail. So let me delete this. Oh, before I do that, so you do recognize that the points have coordinates already. So what we'll be doing next is to extract the y values, which is the 1345, 0.625, 1344, and so on and so forth. Okay. Let me delete this first. So right now what I want to do is actually to extract the y value coordinates of each point. Right, so what I'll do is to use the deconstruct point command. So what this does is actually to accepts the point and it outputs the different components. So if you hover over the x component, what this does is it actually reports all of the x values of the different points in the list. always remember that this output is a list of points, and then it gives you a list of x values of the points in that list. Here we get the y values of the list of points. We have the z value of the list of points. So what we would like to do is get the y values. So again, we use the panel to understand better. Yeah, so we have a list of points. Actually, what I realized is the values are very small in changes. So this is possibly due to the fact that we are having a very small grid. So what I'll do is I would change the length of the graph line to be much bigger. So, and I realized that I can't go any more than 10. So what I can do is I can actually change the range of values I can use in the number slider. So to do that, I have to right click the component and press edit. So here you see a new pop-up window, and under numeric domain we have minimum and maximum. So as you see just now, we have a minimum value acceptable of 0 and a maximum value acceptable, which is 10. So what I will do is maybe to change this upper limit to 100. Maybe 300. Okay, and as I press OK, and over here we see a RNEO, which means this is like the floating numbers, which is decimals. We have integers and we have even numbers and odd numbers. What this does is we will actually limit the selection of the values within that maximum and minimum range to a certain format. So we would like integers in this time. Okay. So what I'll do is actually to extend it much bigger. Let me see. Okay, so double click to change the value manually. 100. Okay, let me zoom it out. We would like to change the intervals as well. So it's currently governed by this factor, and instead of moving the lines only by 1 unit, we would like to move it by 10, maybe 100. Let's double click. 10. Enter. So now we would like to move the lines by 10. So basically you're scaling the graph. And you would like to actually scale this one as well. So what I'll do is to scale in Rhino. We find a base point. And maybe I'll use 10. Okay. Now we have a bigger scale of a graph. Let me zoom out to see the values of that corresponds to the radius of the floor plate that we're going to build in Rhino. Okay, this looks better. We have a difference of, I don't know, it looks like it's 13 minus 6. Yeah. Okay, let's just see what happens. So we have all these values, but this is not helpful because we will actually only need the change, the actual y values. And we know that this point has also a value that's not 0 yet. So we actually are interested in the difference in the y values. So what to do is we will need to get the y value of the origin. Origin we say in Grasshopper, but in Rhino it's actually not the origin of Rhino. So we can actually take the y values and make it 0 to see the actual change. So always recall deconstruct is to report the values of a point. Let's see. When I connect the origin and I connect the y component. So this is the y value of the origin point here, right? And let's bring the panel all the way here. Yep, and these are the y values of the other points. So we will need to know what is this value corresponding to the vertical distance from the origin here. That would be done by having subtraction. You can type subtraction, or you can use minus, enter. Okay, so A minus B, so which means this input minus this input. We will need, as you know, all these are actually above 0. So, I mean 0, if we assume this y value is 0, so we would take this upper value minus the origin. So this is the result. Double click. Okay, so we have 35, 42. Yeah, we realize it's actually correct. It's corresponding to the values here. It's going increasing and then decreasing and then increasing again. So these are the values that we would like to pass into the radius of the floor plates. Alright, so this is part 2. Alright, good job so far for following it. Now, we have to create the third part of the code, which is to actually create the building itself. Some of you might actually do the other way first, but for me, I just thought of doing the other way first, which is more complex. Because I already had the code in my head, like I know the overall workflow. I know that I had to have a list of points, I had a list of values that would be passed into the list of radiuses, that will be passed into the list of curves that I can generate from the list of values that I can use to loft and to create the building. So what we're just lacking now is the last part of the code. Alright? So, and also possibly the most important. Okay. Alright, let's go to perspective. We can use... Okay, let's use another point and reference it in Grasshopper. Point. Set one point. Okay, so this is my origin of the building. Let me change that to origin. Again, right click the component and change the name of building. Okay, I would like this origin of the building to be the center point of the first floor plate, but also the origin of the whole building. That means the center point of the base of the building, right? And we will need to create points that corresponds to the center point of each floor plate in the building, each level, right? So how is this accomplished? We can do that by creating another line, either a line or point. Okay, let's try a different method. Because previously I used a point and then I created a line. Let's just do that to show the difference. I mean, you can always do to get the same output, you can do it in multiple ways. Okay, this is the point of the origin, and we need to create a line. So I want to create another point to the uppermost floor. So I would create a point by using the move tool, and let's say I want to create a number slider that corresponds to the height of the building. Right. Number slider. Maybe let's put it as 300. So let's use in this case, in Rhino, so we are talking about the Z vector now. Unit Z. You can see the bottom left, we have all the coordinate planes direction. And if we would like to have a 3D model, we will need to follow the 3D coordinates. So in this case, we are using the Z vector. So I would like to move my point 300 units in the Z direction. Oh, is it too little? Oh, it's here. Alright, this is what I want. So 300 units in the Z direction. Let me orbit a bit just to see the difference. And once we're done with that, we have 2 points. We can create a line now. Take the origin point as the input, and take the new point that we just created as the uppermost center point of the building. Okay, so we have a vertical line, right? And we can divide curves. So dividing the curve to find the points within this line that corresponds to the center point of the intermediate floors. So what I'll do is to divide curve, which means I want to divide this curve, which means I need to connect this to this. Count. It's asking for the number of segments. So in this case, we have a default value of 10, but I would like to connect it to my levels. Here, number of levels. I have to zoom out and maybe zoom out even more. I'll connect it to count. So right now, if I'm toggling between my graph and my actual building geometry, it will be the same number, which is what I want. Kings, you set a true or false, but I don't need it. I don't need to segment it all. And I have the output of points, tangents, and parameters, which I don't need to use. I will need to use the points. So what this means is that I can toggle and to play the number of levels, and that will correspondingly create the number of levels in my output of the geometry in Rhino. Okay, we are getting close. So now with the points used by this method, I can show you the other way. Okay, let's take this out. I would disable this. Okay, the other way you can do this is to use the move tool as well. We can create a series. So series is another important component you can use. And we can use, so in this case we would like to play with the points instead of creating a line, and then you divide the line into points. So what a series does is to give a we give a list of numeric values based on a certain sequence or certain interval requirement. So if I start from 0, and if I specify the step size, which is how far apart is the first number to the next number of the series, and basically the number of values in the series, which means we would like to start from 0. So we hover, 0 is the first number, which is what we want. Step and count. So the count is the one that we will be changing. So we will connect the number of levels to count. We have step would now correspond to I will actually be tying this to the unit Z vector eventually. So okay, let's have a number slider. 20, 25. Let's move it away. Okay. To always double check what you are trying to output, use the panel. So this is assuming that each floor is 25 high. And I will use the unit sec. Okay, moves out of the way. Now I'll connect these numeric values to the input that will specify my vectors. Now if I use the panel, just do it in a simpler way, connect it to the panel. So now I'm creating Z vectors of move the first point, actually don't move the first point at all. In the second point we move it by 25, 50. Actually what I will do is I would start from 1. So I will right click the start input of the series component. I would set the number and I put it to 1 and 1, enter. Okay, always remember to click the green tick. Alright, so we have a list of vectors. Maybe I'll put it to 24 so that it is nicer. Actually, it's still the same. So let's assume that each floor is 25. You know what? Let's start from 25. Oops, something happened. Okay, this is good. So we have a vector of 25, Z units followed by 50, 75, and so on. So this will create the list of points. So if I plug it into the motion vector with input and also connect my origin, yeah, so you get the same output. And now you can adjust. Now you're adjusting the floor height in between as compared to adjusting the overall building and then dividing the line into points. So right now what I would like to do is not use this, because actually in the real world I guess your building is fixed. What I will do is actually to enable this again, crossing window, middle mouse button, enable. Okay, so now I'm back to the first method of creating the points. Yeah, and okay, so we have this value and we can adjust the count if we want, or we can adjust the overall building height, or if you use the other set of components, we can adjust the floor to floor height. Okay, so now we can pass all the points, the list of points, and to create circles from them. So right now what I will do is to create circle. So always don't use the black polygon if you want to create geometry in Grasshopper. So what you will actually use this one. Create a circle defined by a base, plane, and radius. Left click. Okay, so now the plane that we were actually interested in is the XY plane, which corresponds to, a surface that is parallel to the ground plane. Radius, so this is what we need to input, and we will like to input a list of values for that. So, and if you also pass the points into plane, it automatically assumes all the points, and actually in turn it is trying to determine that these points are the origin of the circle and then XY plane. So for the radius, corresponding to the list of, in this case, 8 points, because we have placed 8 as the number of levels. 7. We have to pass similar number of values, and if you have done this right, we will have the same number of values, 7 values, that we can pass it into. So we go back all the way to the second part of the code. The first part of the code, which we have the values of the y values of the coordinates. We will pass that in to the radius. Left click and drag. Alright, so now we see we created circles of different radius based on the input graph. Let me toggle back to the graph. So now if we change the curvature, maybe I make the middle stories higher, bigger. So we get a higher y value corresponding to the bigger radius in the intermediate levels. And then it slowly tapers off. Let me orbit this a little bit. Okay. We're almost there. Right now we have the circle curves corresponding to the floor plates of each Larry. What we can do next is actually to loft the curve to make a continuous surface for the facade. We can do that by typing LOFT. Yeah. And we will like to pass the input of the list of circle curves. And now, here we go. So we have a very beautiful parametric geometry representing a building. And yeah, we can still continue to play with the curve. We can tweak the number of levels. And maybe you can adjust it again. Yeah, we can also play with the height. Yep. And since it's already done in Grasshopper, we can also analyze the geometry. Remember, we can creating as one thing, but we need to analyze the geometry as well to be able to either construct it or to evaluate it. So let's say we want to get the area. So we can use the area component. Enter. So this is actually requesting for planar closed curve, which is what we have. We have a list of curves from here. Again, use the panel to see that we have a list of circle curves. We can pass that into the area, and now we have the list of area values of each curve, like so. And we can use the display components such as the tag, text tag. So it just shows your any either string or numbers in a text form in Rhino. I will pass these values to this text. The location will be the center, right, which is the center point of the curve that we just evaluated for the area. Alright, so now we have all of these values. Yep. So we have the first point, which is at the bottom, 6803. So 6803 is the area of the bottommost level, and then we have 12,000 and so on. Yep. And we can continue to play with this. We can go back and maybe let's say I want 10 stories. And then maybe I want a very boring building. Yep. Yep, the fun doesn't end here. So what you can do is to bring this geometry back into Rhino. We have to do this by the bake method, B-A-K-E, you know, baking oven, baking cookies. Yep, bake geometry into Rhino. What we can do is select the component that is outputting the geometry that you want. We can right click and we can press bake. And for now, we can use the default. Let's say if you want to group your output, we can do that in here. But now we will just need to press OK. So what this does is actually see now is a gray Rhino object. And yeah, so we have managed to create form that we would like to save. Maybe you want to transport it into Rhino and to model it further, or to maybe 3D print it, or to perform other operations in Rhino. And always know you can actually continue to play with the values. Let's see. Maybe now I don't want. You want a shorter building. Change the name to height. Yeah. Maybe I want like this. maybe I want a more complex one. This will definitely not stick unless it's a very strong core. Yep, and then I can bake this as well. Under loft, right click, bake. Okay. Use a gumball and then move it around. So yeah, so now we have many different options that we can play with the building. And let's say if you want to split, I don't know, you want to have the curves outputted as well. So what we can do is actually we can use the group. We can use the curves as well as the loft. Oh, one important thing, how do we combine inputs from different outputs? So we can use hold the shift button, and there you go. We have combined the list of, in this case, the loft. Actually, I don't want the loft. I want the list of curves, and I want the list. Yes, the list of curves and the loft surface itself, and we group them into one output. So now we bake this. Right click and bake. Okay. We have the lofted surface as well as the curves. Sorry, I also moved the point. Let me show you a pro tip. This is the selection filter. Yeah, this one. So if I want to select only the curves and not the points, I will just uncheck the point and select. Because at this, just now I moved the origin point that is referenced in Grasshopper. So actually the whole geometry from Grasshopper move as well. But now if I don't select the origin point, let me uncheck the selection filter. Yeah, the point is to here. This is a point that actually governs the Grasshopper object. And after baking it into Rhino, now I have a group of lines. Maybe I can ungroup them. Right, there you go. I got the curves and the surface. Maybe you can use cap holes to get the closed geometry. Yep, loft. This will give you a closed surface. Bake. Okay. Now move it away. Now you see an extra surface. If you type properties, and I minimize, so close solid point surface. So we actually managed to close off the top and bottom surfaces, and this is good for 3D printing. Alright, so we have done a lot today. We have managed to replicate the code that I did a few days ago, and I hope you have learned something during the process. It has been a long journey. One tip that I can impart is always think about points, vectors, and lines, and think about the data structures, lists, think about list methods, and yeah, if any questions about Grasshopper, you can actually comment down below, and I would try my best to respond. I would think that list methods are next to cover. Let me quickly show you how to use list methods and to apply it to any Grasshopper scripts. So, list methods. I think that is the only thing that is missing from this code that I haven't really used. You can try to, let's say if I want to select the list of curves at every second story, that means every second level. So let's say list list item. This is the most interesting and commonly used ones. So what this needs is a list, and we have a list of curves, the circles, the green ones, and the index. So if you recall, index is a label of the position of the item in the list. And in order to select every second item, we will need a series that starts from 0, and then the step is 2. Right click, set number 2, count. We would tie it to yeah, let's try this first. Let's see what we get. So we actually select. No, it doesn't. You know why? Because it actually goes select 2, 4, 6, 8, and then goes back again, and then you actually duplicates the other ones. So what we need to do is we have the number of levels, we have the step, we will need to divide this by 2. We can do it such that you can use a data item. So B will be number 2, and then we can use the number of levels. I mean, right now I'm just trying to play by ear. This shouldn't be step. To disconnect, you can just right click and then press disconnect. Yep, so now we have successfully selected every second curve. So list item is a component that takes the list, and then we have to pass in maybe a list of indexes or a particular index. In this case, we have passed in a list of indexes, but you can always use only one index to pick only one item. So now we have outputted the circles that have been picked with the index list. And what else is there for list? Let's see. The other things work quite similar to that. We can insert an item. So we need the existing list to add into. And the item may be, let's see, maybe let's create a circle somewhere. And then we can create a curve. The reference in Rhino. Set one curve. We can put this as a new item. And then now we're asking, which index do we insert this new curve into? So let's say we can set it to 2. So now we have inserted the item into the list. As you see, we have indicated we would like to actually insert this new curve into the list of curves in the building at the second index position. So all the list methods work quite similarly. It will ask for the list, it would ask for a certain index or maybe a direction or items that we would like to insert or replace, or to even split it at what particular index. Yeah, so in the next video, we will probably touch on it in detail as I go through my breakdown of a project. And I hope this video has taught you a lot of workflows and components and the interface basics of Grasshopper. And if you would like to know more, I can recommend a few resources. Let's go to my internet browser. Alright, the first resource I can recommend is the Grasshopper Primer. So you can search a Grasshopper Primer on Google search. You get from ModeLab a PDF that is free to use, or you can use the online version as well. So if you hover over the foundations, we can actually take a look at all the data structures. We can see the extensions. We can use, let me go back to the components. Yeah, some of them are actually third-party plugins. We can have a look and download for free. We can also take a look at Food for Rhino, which is a portal of plugins and scripts for Grasshopper. We can also use one resource I can recommend is the Grasshopper Primer from ModeLab. This is a primer that helps you to understand all the different components required and accessible in Grasshopper. So you can view it online as well as the PDF. And I will recommend this to those people who are interested in knowing all the components that are in Grasshopper. You can also download the supporting files to actually have a go yourself. And next we have the Food for Rhino, which is a portal for plugins and scripts for Grasshopper. We also can recommend the Grasshopper forums that the community has actually contributed and asked questions and usually are met with answers from the community. We also have all these sample files that you can actually explore, FAQs. Yep. One way to search through is to use the search bar and to select for maybe if I'm encountering problems with the plugins or maybe outputs, or not sure of how to actually have the overall workflow in mind, or what components are actually possible to use to create the outputs that you want. This is the place to find the answers. So, in the next video, we would cover a project of mine, and just to reiterate, we will go through the thought process and the Grasshopper script, as well as to maybe give you some context of the project and that I did during my architecture school, and how all this plays out in parametric design. And yes, so that's about it, and I hope you have enjoyed learning with me. Stay tuned for the third video, and if you have any comments or any questions, you can always DM me at ARCHLOGBOOK on Instagram. Till the next time, have a good day. All the best. I'll see you soon. Goodbye.